Hello friends, welcome to another interesting video in communication systems. We'll talk about random variables today. We'll thoroughly understand what a random variable is and what is the probability distribution of a random variable. We'll see the types of random variables and we'll see all that with the help of examples. So if this is something that interests you, then please keep watching. Now when I say a random variable is nothing but an event that could occur again and again so that we could record the outcome of that event in order to plot the probability distribution. Now, what does that exactly mean? We'll see that with the help of examples. And by the way, random variables are of two types, discrete and continuous. So we'll take examples of both. Now let's take up an event, rolling of a dice. Now what happens is when we roll the dice, what are the outcomes? We know that the outcomes could be either 1, 2, 3, 4, 5 or 6. And the probability of occurrence of any of these numbers is equally likely. So if we were to plot the probability of rolling of a dice, which is let us say P of D, with respect to the outcomes are the variables. So we'll see that it has only 1, 2, 3, 4, 5 and 6 as the meaningful outcomes, and all the other values up to infinity and up to minus infinity, 0, minus 1, minus 2 and all those values, they are needed to be plotted in the probability distribution function or the probability distribution graph. But the fact of the matter is only these values 0, 1, 2, 3, 4, 5 and 6 will have the probability of occurrence equivalent to 1 by 6, and rest every discrete value will have a probability of occurrence to be equivalent to 0. So minus 1 has the probability of occurrence as 0, 0 has the probability of occurrence as 0 and so on. Now, why is this known as discrete? Because between 1 and 2, between 2 and 3, there is not even a probability of happening a 1.2 or a 2.5. So between these two values, it is not that the probability is 0. These do not have any meaning at all. So these are not defined. So this area is not defined and it is defined only at discrete values. So that is why it is known as discrete random variable. Another example that we can take is the drawing of a card. And we know that if we were to draw a card from a deck, a shuffled deck, then the probability of occurrence of a particular number is 4 by 52. So we can say that the happening of A, which is 1 or 2 or 3, 4 up to, they all have the probability of occurrence to be equivalent to 4 by 52. So what becomes the sample space of this random variable? This random variable is defined for A to K, and for the entire space, all the other discrete values will have the probability 0. You know that anything beyond, if we were to label this as 13, anything beyond 14 will have a probability of occurrence as 0. And similarly 0, minus 1, minus 2 will have probabilities as 0. And only these values will have probabilities which are equally likely, and they will have a probability of 4 by 52. So we know that there are 4 2s in the total of 52 cards. So the probability. Another example of discrete random variable that I can think of is it is pretty random. Let us say the number of gems in a 100 grams pack. Now we know that if this is a pack of gems and it has a weight of 100 grams, we do not know how many gems will come out of these packs. But they are surely going to be discrete in nature. We cannot have 10.5 gems or 9.2 gems. So we'll have either 10 gems or 8 gems or 7 gems, depending upon some lot of manufacturing could produce a higher density gems or bigger size or smaller size. So depending upon all that, if we were to count the number of gems here, let us say, so we get 4, 5, 6, 7, 8, 9 and 10. So we get 10 gems here. And if I was to open another pack, I could get 11 there. Or if I was to open a pack of a different lot, I could get 15 also. Their size could have been smaller, but because the weight needs to be 100 grams. So this is how we need to distribute the probability of this. So if we were to plot the probability versus the variables values, so I could say 10 is something which has a very, very high probability. So I could say 70% of the time the number of gems that will come out will be 70%. And then I could say that 9 has the probability of occurrence as very less probability, let us say 0.1. And similarly, and we could say that 11 gems could come out of the pack, has a probability 0.1, and rest 8 has even smaller probability, 12 has even smaller probability, and 7 has even smaller probability, like this. And you could distribute this probability to some numbers like 14, 15 on this side and 6 or 5 on this side, but it will not go up to minus infinity or infinity. It will have finite number of samples in its sample space, and the sum of all the probabilities is going to be 1. So that is very, very important. So we know that the sum of probabilities of all possibilities is equivalent to 1. Now, keeping this thing in mind, we have a generalized idea of what a random variable is. So it need not have equally likely events all the times, as I illustrated with the case of gems. So we could have some event which could be discrete and still have a non-uniform probability distribution. Now, if you were given a question like this, where this function represents the probability distribution of some discrete random variable, so we know that random variable has some probability at -2. The probability of happening of -2 is 30%, the probability of happening of -1 is 20%, and the probability of happening 0 is a, and so on and so forth. So the function will be drawn for all the values of discrete possibilities ranging from -infinity to infinity. However, you will have non-zero values for only those discrete values for which the experiment occurs, experiment gives an output. So this could be any random event. Now, if you were to answer these questions, that if function is PDF, which is the probability distribution of some random variable, then determine, the first thing that it asks is to find the probability of all the events where n is less than -1. So we know that this function has only one possible value less than -1 for which it gives an output, and that is -2. So the probability of this event for all the values which are less than -1 is just 30%, or we can say it is 0.3. Now again, if you were to answer this question that you need to calculate the probability of all the events so that could be asked like this. So in this case, you will need to add the probabilities of -2 and -1 because less than equivalent to -1. So all the samples, -1, -2, they add up to 0.5. So if we were to calculate the probability of this function between -1 to 2, we simply need the value of a, and n should be less than 2, so 1 will be included and n should be greater than -1, so 0 and 1 are required here only. So let us first calculate the probability of occurrence of 0. We know that this sum of all the probabilities is 1, so I can say 0.3 plus 0.2 plus a plus 0.1 plus 0.15 plus 0.15 is equivalent to 1. The summation of all this function ranging from -infinity to infinity is 1. So once we know this, we can find 0.5, 0.6 and 0.9. So a becomes 0.1. And the probability of this is probability of occurrence of 0 plus probability of occurrence of 1. So that will be 0.1 plus 0.1, which is 0.2. And similarly, you could be asked to find the probability of occurrence of this event for a value 1, which is 0.1. So this is pretty easy. And what about the probability of n, let us say greater than 0? Greater than 0 is happening for this value, and this value. So this is 0.1 plus 0.15 plus 0.15, which will be 0.4. Probability of n greater than equivalent to -1. So you include this -1, 0, 1, 2 and 3, all of them, or simply subtract the probability will be total probability of the function minus probability of happening of -2, right? So this will be 1 minus 0.3, this will be 0.7. So probability of occurrence of this event for any value greater than equivalent to -1 is 0.7. So this is how pretty easily you can calculate the probabilities of a discrete random variable if the PDF of that random variable is given. So I hope this tutorial was of help. If you liked the video, give it a thumbs up. I'll see you around. Take care. Bye bye.